Hey 7th grade, this video is for our Eureka mid-module 3 test. So as this video plays through, you'll see first the question and then the answer is just going to show up with a really brief explanation of where the answer came from. The goal of this video is to show you how to solve it so that way when you continue the demo test on those blue problems, you have something to refer back to. Okay, here on 1A, you can see that I used the distributive property up on the original expression to distribute my -4 to the 3x and the -y, and the 0.25 to the 4x and the 8y. Once I brought down that expression right here, I boxed in each term, and then I used my highlighter to identify like terms. So I've got two, the yellow being the x's, the blues being the y's, and then I just added my coefficient. For 1b, I looked at that expression that's right there in A, and I said, what can I divide out of both of them? Since only the 9 is negative, I can't divide out a negative value per se, so I left it positive and got my answer to be. Here in 2A, you can see that I've underlined important information, and I brought in the expression from the word problem. Ultimately, I found that over here, A was x, and x equals 1. Then B down here on the base, well, it says the longest side is 12 more than the shortest side. So I added 12 and got my 13. And then for the final one, it says the third side is 3 times. 3 times 1 is 3. Here on problem B, I again underlined important information. Then I was able to set up my expression. Since area is a multiplication concept, I had to use my distributive property. Then I solved the multi-step equation, found that x equals 2 over here on the right. Since x equals 2, my length, which was x plus 4, equals 2 plus 4, which equals 6. And then I went back up to my diagram and labeled it just because. You might recognize problem 3 from classwork we did in this module, where we were trying to figure out how much space there is around the picture and keeping them equal on the wall. So I'm definitely going to draw a diagram, and let me show you how to solve this. Here for problem 3, you can see how I've solved it both ways. So the question asks you to solve it both arithmetically and algebraically. So up here in the red highlighted area, it's arithmetically. I know that there are 2 spaces. I just refer to them as an abstract gap. So once I get down to the remaining wall space, right here at the 3 1/3, I naturally know to divide by 2. On the second part, on B, where I solve algebraically, I use x as a placeholder for those gaps. And then therefore, once I group like terms here on this purple, I have the 2x, where I'm still going to divide by 2. You can see that on both problems, I end up with the same 1 2/3 answer. For C, it says compare the approaches. I wrote, these approaches are similar because they both use subtraction and division to solve. For A, it says 8 pairs of socks for $3.25, 4 pairs of shoes for $D. He spent $122.85. Write and solve an equation. On this one, guys, you got to make sure you show your equation, which is right here in purple, and then solve it. If you don't write and solve, you will lose points, okay? Make sure you're showing everything you're typing into your calculator. The question goes on to say, on the following day, he returned to buy more socks. It specifically says that he had $30, so that's what we're going to subtract away from. So first here you can see the cost of the shoes plus the number of socks needs to be less than or equal to 30. That's where we're at with this inequality. Let's start to solve here. First, I found out how much the shoes cost, right? Because we need to take away that amount of money in order to know how much money remains for Corey to buy socks with. I ended up here with $17.89 left to spend on socks. Then I came to this final step. I divided my $17.89 by $3.25 and found that he can buy 5.5 pairs of socks. As you know, you can't buy half of a pair of socks, so we rounded down to 5 pairs. Okay, I decided I wanted to walk you through this inequality. I've highlighted important information. We know that he can spend less than or equal to $60. Well, he's going to pay $35 just for being there, plus $3.5 a person. Now in B, we're going to solve it. In this inequality, we're not looking to see how many items he needs to sell to make a profit, but rather we're looking at the $60 he has and looking at how much of it he can spend on bowling tickets. That's why my 35 here is a positive value, not negative. So let's start by subtracting it from both sides, because then that would tell me how much money I can spend just on tickets. That gives me a 25. So we have $25 left over, divided by $3.5 a person, and that gives me 7.1, so 7 people. Which, for this scenario, it's 6 friends plus himself, right? Because that's 7, that's why it says including himself. For this scenario, I've chosen to use a solid circle on 7 because my symbol, if you remember from this problem right above it, was less than or equal to. So he could have 7 people at his party, but he could also have 6 people, 5 people, 4 people, and so on. All right, this question's a little trickier. Naturally, it's toward the end of the test. It's the second to last one. So I'm going to take a minute to highlight important information and then kind of break down how you solve it. I like this problem because it's really relatable. We have Miles and Brahim. That's 2 people that are paying 1 rate. So let's just use T for their tickets. T is 3D movie. Because it says define the variables here, so I went ahead and defined. T is a 3D movie. Plus, we've got the mother, the father, the grandfather, the grandmother, and the little brother. 5 people seeing a regular movie. R is regular. It's really important to define your variables on a problem. Equals X. X is total cost. Let's move on to B. Now we all know 3D movies are more expensive. Here it says it's triple the cost. So instead of using a T, we could say it's actually 3 of the regular. For 1 T, be 3 regular. Now we can move on to C where we actually solve. Let's break down this expression I just created for a moment. We have the 5 regular from the parents, the grandparents, the little kid. We have 2 of the 3D movies, but if you remember, we've substituted in, instead of saying T, instead of 2T, we have 2 of triple the regular rate. So now we can go through, consider the concessions, total cost, and solve. Here, looking at the problem, you can see I used the distributive property on my 2 and 3R, which gave me a 6R. I collected like terms and got 11R. Then I have this concessions amount here, so the first thing I did was I subtracted that from both sides. I subtracted it from where it was added on, and I subtracted from the total, and I found that 11 tickets, 11R, came out to $74.35. When I divided that, I actually got 7.21363 ... And so then I just rounded it to the nearest dollar, and there's my final answer. All right, last question on this demo test is a geometry question. Overall, it says solve to find X. So that's what I'm going to do here. Since I know that these 2 angles are vertical angles, right? They're across from each other right here on this intersection. They're congruent. So I set them equal to each other and then solve my 2-step equation. I did have to use the distributive property to get this layer right here, but that's a no-brainer. For this last question, to solve for y, I'm using this line that I've highlighted up here in purple, and I know that these 3 angles add up to 180. Since I know 2 of them, I know the 18 and I know the 56, I can subtract away from the 180 to figure out what 1/4 y is. When I do that, pardon my pause, this gives me 74, so when I take 74 away from 180, I get 106. 106, well that's only fourth of y, so I'm going to multiply that times 4 and find that y equals 424. So that's my answer.